this is going on 31 when we're done. I'm going to take you back. It's okay if you're not looking at yours, but I'm going to take you back to what we did on Friday. We talked about instantaneous rate of change, right? With all this nonsense. And we have the m because it was the slope, right? Our instantaneous rate of change is the slope of the tangent line at that point. So when we're looking at this, just a little quick review on this, the slope of this function, the curvy function, at x equals -2 is the slope of this tangent line that we found right there, right? And so that is a derivative. Okay, we're going to talk about them some more. We're doing this a little bit, seems a little bit backwards than from what we did last year, because I'm like, we're talking about derivatives, but we really haven't talked about what a derivative is yet. You'll be fine. The derivative gives you the slope of the tangent line. So this slope, and we're looking at it as a limit right now because we don't know how else to do it unless it's given to us, and we'll be given some stuff. But this is one of the notations for the derivative. All it is the instantaneous rate of change, which is the slope at that point, okay? And for us to find it right now, because we don't know any of the shortcuts, if it isn't given to us, we find it using the limit just like we did right here, okay? So we'll look at one of those today, but we'll have some, we're really going to talk about the notation and writing the equations of the lines first. So tangent lines and notation. So there are several ways to indicate a derivative, right? Even though you're not 100% sure how we find all these yet, it's okay. If I have this function y equals f of x, then the derivative can be written a couple of different ways. So the derivative of f of x can be f prime of x. So it's like an apostrophe. Like if you were typing it, you'd type a little apostrophe there. It's not a 1. Okay? So f prime of x, that's how you say it. Let's put that in little quotes here. F prime of x. Okay? And then another way to do it, which we don't use a whole lot, but you might see, is if we're calling it y, it could just be y prime. That's another way to do it, is just y prime. And then the last one, so really 1 and 3 are the ways that we'll see it the most. Looks like this, dy over dx. That's the derivative of y with respect to x. That's one way to say it. But the way we really say this when we see it is really just literally dy dx. You don't even have to say over, it's just dy dx, and you know what it looks like. Okay. We're going to use the f prime version of that today. We use that a lot, and then there's reasons that we would want to use the dy dx. We'll get to all those later, but these all just mean the derivative. Okay. So when we want to write an equation of a line, so reminder, a derivative tells us the slope of the line tangent to the function at a given point. It's going to give us the slope of the line tangent to the function at a given point, because our rate of change changes, right? Our rate of change isn't constant the whole time. If we have a curve, our rate of change changes. This is going to have to jump, and then I have to put it back. Sorry. There we go. Okay. So we also want to write equations. So not only do we have the slope of that tangent line, we want to write equations of tangent lines. Okay. It's key to remember that a tangent line is just a line, meaning you've been writing equations of lines since Algebra 1. Okay? It's really that simple. We're not writing any kind of crazy stuff. It's literally the equation of a line. To write an equation of a line, we always need two things. You need a point, and you need a slope. Those are the two things you need every time, point and slope. And I told you on Friday when we do this, every time you see write the equation of a tangent line, we literally write down point and slope and make sure we fill those in before we go making stuff up. So if I'm going to write the equation of the tangent line of f of x, okay, at x equals a. So a is just a number. So this would be like the line tangent to f of x at x equals 5, or whatever it happens to be. It's just a. So the way you find the point, every time the point is just a, because that's whatever that x value is. And then this is the function value at a. So it's like x comma f of x, right? The slope is just going to be f prime of a. Well, not x, of a. So it's the derivative at x equals a, whatever a happens to be. There are 3 different ways that we can write the equation of a line. 3 different forms. Anybody give me one of the forms? What? Point slope. Okay, so we can have point slope. So we'll say this is point slope form, which would be y minus y1 equals m times x minus x1. Right? And then what's another way? Slope intercept. So slope intercept, which would be y equals mx plus b. That sound familiar? Anybody tell me the third way? Probably not, and that's okay. It's standard form, which you do a lot in like algebra 1, and then you really kind of don't use it very much. Looks something like that. Oh, no, that's by. Good Lord. by equals c. Yes? Which one is the king of all that we really should latch onto? Point slope, absolutely. Point slope. Slope intercept, we use if you are literally given the y-intercept and the slope, you can just pop it in there. If you have to do anything to solve for b, you are doing too much, okay? This is the king of all. Now, this is the way you do it in Algebra 1. This is the way you would have probably done it in geometry if you did it at all. This is how we did it last year in pre-cal. But what we want to kind of get to, and you have one of 2 ways to do it. You can go directly here and then do the next step, but we're going to write it a different way. You have y minus y1 and x minus x1, right? If we want to solve this for y, we can start off that way and just have y equals m times x minus x1, and then it would be plus y1, right? So this is kind of how we're going to adjust this. We're not really changing this. You're still kind of doing it the same. But instead of minus on both of them, because we're moving it over here, it becomes plus y1. You with me on that? Okay. Which means that if I want to write this, now we're going to write this and it's going to look super crazy, but we're going to put the stuff in there from here, okay, using these 2 things. So my equation would be y equals, my slope is f prime of a, right? So I've got my y and I've got my m. Then I'm going to do this part right here. Then I'm multiplying that times x minus the x value, which is a, right? Plus this y value, which is f of a. But all that stuff just comes from here. So this is what really goes in this blank, but you thinking about it this way, it's the same thing, and it looks not nearly as intimidating as that other one, okay? But that's how it all fits in there anyway. We good with that? Questions? Okay. So we come down here. A function f of x is continuous. So that's nice. Anytime you see continuous, see, this is what continuous and differentiable. Anytime you see those things, differentiable means we can take the derivative. Okay, those are important keywords for us to be able to explain things later. Always underline them, circle them, something, because it may be something you need in an explanation. For all values of x, so we know this and this. We want to write an equation of the line tangent at x equals 4. So since we want that, we write point and we write slope. And right now we're given a lot of information, but we're going to write it as if we don't necessarily have all the information, okay? I want the line tangent at x equals 4. So the way I get my point for that, and this is called f, so the point is going to be 4, comma, f of 4, and the slope is f prime of 4, okay? Because sometimes we have to go find that stuff. Right now, a lot of it's given to us because it's kind of it's the newish part of what we're doing. So do you know what f of 4 is? It's 7, right? They gave it to me. So that means this point is really 4, 7. Do you know what f prime of 4 is? 2. It's right here, right? So that's equal to 2. Do we have enough to write the equation of the line? Yes, we do, right? So we do y equals the slope, which is 2, times x minus this x value, which is 4, plus this y value, which is 7. And again, you could have done y minus 7 and then moved it over. Or you could have left it over there also. Right now, it's not the end of the world. But there are reasons we kind of want it like this. We good? Easy enough? You can write the equation of a line, right? And we're just pulling stuff out. But there's a reason I'm making you write all of this, just because, like I said, you're not always going to have all of that. So let's do that again here. So the function g is defined as this right here. And it's known that the derivative of f is defined, this really should say the derivative of g, not of f, is defined as g prime, this right here. We want to write an equation of the line tangent to g at x equals -1. Right? And I know that you have these words down there, but we're just going to pretend like they're not there. And you can kind of write around them or whatever you need to do. But I need my point, and I need my slope. So my point is going to be -1 g of -1. My slope is g prime of -1. And I'm going to need to find these things, right? So I can find g of -1. How do I find that? Substitute it into the g one, right? So this is going to give me -1 squared minus 3 times -1 plus 5. So this gives me what? 1 plus 4 plus 5? Just 10? Is that right? I'll stop me if I'm wrong. Make sure my numbers are correct. No. Oh, shoot. That didn't correct me. I knew it didn't seem right. What did I do wrong? 3 times -1 is not 4. This right here is 3 plus 5. You know, we're all like, yeah, you're right. There we go. It looks good, right? I was semi-confident. Whatever. All right. So that means that this point right here then becomes -1, 9. And then I know you don't have tons of room, but now I need g prime of -1. So g prime of -1, how am I going to find that? I substitute it into here because they gave me an equation for that, right? Let's see if I can do this one correctly. I'm going to do 2 times a -1 minus 3, -5. Okay, and so this is equal to -5. And what I was about to say before I realized my 10 should have been 9 was you don't really have to write all this out as long as you can come up with the right number. I wrote it all out and still couldn't come up with the right number, so it's pretty good that I wrote it out. So it's not like that you have to show every single step, but be careful so you don't do dumb things like I just did, okay? And then you'll all follow me along. Okay, all right, we good? Everything? Write the equation of your line. That's what I got. Don't just blindly copy me. You should have learned that by now. Okay. Are we all good? Any questions? Just got to find your stuff. You're writing the equation of a line. And nobody's going to give you the y minus y1 stuff. You got to know how to do that. And we're going to do it so much you're going to know it. It's just be hard to mess that up, I think. Okay, so that was given equations. You can also be given a table of values, like a lot. So make sure when you're given these table of values that you pay attention to what the labels are so you know what the heck you're looking at, okay? So we have the function h of x is differentiable for all values. So if it is differentiable, because we'll talk about how do you know if something's differentiable. If you see that word, differentiable means it also has to be continuous. So you know how when you had to explain, hey, f of whatever is continuous, you can say since, not that we have to say that on this one, but I could say if I had to prove that since h of x is differentiable, then it is continuous for all values x, or something like that. So those go hand in hand. Just because it's continuous doesn't mean it's differentiable, but if it's differentiable, definitely means it's continuous. Okay? Sometimes you're flat out told things, sometimes you have to know it for other reasons. So they've given me a selected values of x. They've given me h and h of x values, so I'm not going to have to substitute things in. I just got to figure them out. I want the equation of the line tangent to h of x at x equals 1. So I need a point, and I need the slope. And we're going to write it out the long way. So my point is 1, comma, these are h's, h of 1. And my slope is h prime of 1. Don't have to do a ton of work here, right? I can figure out my point pretty easily. This is going to be 1, comma, what's h of 1? -5. And then h prime of 1, -4. Then write the equation of your line. Everybody good? Any questions at all? It really is this easy. Do we sometimes mess up more on easy stuff? Yes, we absolutely do. So we want to make sure that we're... Okay, so write the equation of the line tangent to h of x at x equals -2. So again, we write point and slope. And then you do the rest. Get your notation all in there correctly. Figure out your values, write your equation. When you're done, compare with your neighbors, see if you agree. Ask me questions if you have them. Oops. Do you agree with everything I have so far? Yes? Okay. So then if I do my y equals the slope, which is 0, times x plus 2 plus 3, right? So that's just plopping it in there. Could I do more? Yes. Do I have to do more? No. So it is perfectly acceptable to leave it like that. Now, if I had to actually graph it or do anything else with it, then actually making it into y equals 3 might be helpful. But, and I wouldn't even, if I know the slope is 0, I know it's horizontal, so it would just have to be y equals 3. But so you don't accidentally mess that up, there's nothing wrong with putting in that form and leaving it like that. If that's what you're asked to do, boom, you did it. Good job. Okay? We okay with all that? What questions you got? Yes, sir. Yes. And so it would be a correct answer, but if you accidentally did y equals 2 because you got it mixed up or whatever, that'd be a bad thing. So that's why it's better just to leave it. If it was a multiple choice question, this is more likely what the answer would be. So even if you get this, you need to understand that it's the same thing, even if you don't do it. But yes, if you do more, as long as you're correct, it's fine and it's a correct answer. You just don't always have to. Okay, good question. What else we got? Anything else? All right, so let's look at example 5. So example 5, we're not using that table anymore. They give us k of x. We want to write the equation of the line tangent to k of x at x equals 3. So that triggers me writing point and slope and finding those two things before I do anything else. So my point is going to be 3, k of 3. My slope will be k prime of 3. We all agree with that? All right, so k of 3, see if I can do this correctly this time. K of 3, I would just substitute it into the k, right? So 3 squared plus 5 times 3 minus 3. That gives me 9 plus 15 minus 3, which I believe is 21. Do you agree with me? Okay, good deal. So that means that my point is actually 3, 21. I need k prime of 3. They didn't give it to me this time, okay? And I don't have a chart, and you don't know your derivative rules of what to do to actually find the derivative, one of the ways you can do it. But the way we did it on Friday, remember I just showed you that a second ago, that we did this using the limits. To use the prime, we've got the instantaneous rate of change, which is your slope, and it's the limit written like this, g of x minus g of 4, and all that's equal to the prime. So here's what this is going to look like here then. We're going to have, we want k prime, right? So k prime is equal of 3. Do the whole thing. That's equal to, that is the slope, and that's equal to the limit as x approaches 3 of k of x minus k of 3 over x minus 3. Okay? That's one way to find the limit. It's the only way we know how to find the limit right now. And this is what I kept messing up on Friday. What did I keep doing wrong every time I wrote it? Left off the limit statement. Do not leave that off. Do not leave that off. Do not leave that off. Reminding myself and you. So because I need to do some stuff with the fraction, I need to rewrite the limit as x approaches 3 of, all right, so k of x is x squared plus 5x minus 3. And then minus k of 3, what's k of 3? 21 over x minus 3. Because if I just substitute in 3 right here, I'm going to get a 0 in the denominator, and that's not going to help me any. I don't even know what's happening in the numerator, but the 0 in the denominator tells me I at least need to do some more stuff. Okay? So then I keep going, and I rewrite my limit statement again. I don't get to stop writing it until I actually substitute in the 3. The limit is x approaches 3. My numerator is x squared plus 5x minus 24 over x minus 3. What do I need to do next? Factor. What are you pretty confident one of the factors of the numerator is going to be? X minus 3. Good. So that kind of helps you with the factoring process, right? Not that it should be crazy hard, but this is going to be, so I'm going to have x, we'll say, I'm pretty sure one of them is x minus 3. So then this would be x plus what? 8. Good. All over x minus 3. So then I can cancel those out, right? That leaves me with the limit as x approaches 3 of x plus 8. Now, I can substitute in the 3, just do it by direct substitution, and that limit is equal to what? 11, okay? Which means k prime of 3 is equal to 11. Now that I have all of that, and if you have completely run out of room, we are not going to do example 6 right now because it does require the calculator, and we just haven't done that yet. We'll come back to this one. So if you need to write it a little bit underneath it or something, it's fine. Then I'm going to write the equation of my line, which would be y equals 11 times x minus 3 plus 21. Okay? What questions do you have? Can you write the, yes, sir. Mm-hmm. Of 3. For right now, yes. Starting maybe Thursday or Friday, before the end of the week, you'll find another way. But right now, the only way you can do it is by doing this. And the reason these are 3s is because that's a 3. And because that's 3. That's where that number comes from. Yeah. We're not on the test tomorrow, but, that's what's happening there. Okay, we good? Yes, sir. Right, there are 0 formula charts on the AP exam. 0. But it's as scary as that may seem, it's really not going to be that bad. The things that may seem a little weird right now, we're going to use them so much, if you're even half paying attention, you'll know them. Okay? Like, it's going to be okay. It's just that it's new to you, and that's so it feels a little weird. You'll be fine, trust me.